Hello, this lesson is about inverse trig functions, focusing on inverse cosecant, inverse secant, and inverse cotangent. So let's look at the graph of inverse cosecant. So if we're looking here, we can see that the domain is really interesting. This is a really interesting graph. Okay? So let's take a moment and just think back on the secant graph. Remember, you had to draw sine first, and then you would draw the u's. Oops, I don't know if I can show that there. A u and a u on the peaks and the valleys, and then you had asymptotes where the sine function intersects the x-axis. So when you take this and you reflect it over the line y equals x, this part reflects over and then this part reflects. So it's really just kind of cool and interesting. And the asymptotes also reflect as well. So if we're looking here, you can see that the domain is in two parts and the graph is in two parts. The first part is from negative infinity to negative 1, and it equals to this is filled and it's going this way. And then 1 is filled and it's going that way to positive infinity. But look at what it is not. There is no graph in between here, right? None. There's nothing between the negative 1 and 1. Very cool. So this is why we have this gap. Okay. Now if we look at the range, it's going from negative pi over 2. That's down here, right? Included there. Going to pi over 2. But if you look right here, it does not include 0. There is no bracket, there are parentheses. So if we look here, what does that mean? There's an asymptote y equals 0. So you can see that these parts are approaching and getting closer to y equals 0, but we'll never touch it. So very, very interesting and cool. So when we're talking about finding the solution of that, which is going to be an angle, similar to its reciprocal function, inverse sine. Positive in the first quadrant, negative in the fourth quadrant, and we can see that. Right. Here's my fourth quadrant, right? Negative pi to 0. Negative pi over 2 to 0, right? That's going to be the fourth quadrant. And then the first quadrant from 0 to pi over 2, 0 to pi over 2, positive. So it's similar to the inverse sine function, right? It's going to be these two quadrants. However, the only difference is you have this asymptote that runs right in the center. So it cannot equal, you cannot have, well, if you had cosecant, inverse of cosecant 0, that's going to be undefined, right? So that's not going to have a solution. So inverse of secant, the domain is the same. But it looks different, the graph. So now this is above. So you're up here going that way, down below, you're going this way. The range is also different. The range now is from 0, right? This is 0 to pi over 2, and then from pi over 2 to pi. So two separate parts, right? Because just like inverse cosecant, you have an asymptote here, right through the center. Now you can see that here, okay, quadrant, just like sine, from 0 to pi over 2. So this is 0, right, to pi over 2. This is our first quadrant. Pi over 2 to pi over 2 to pi. This is our second quadrant. So this is positive and this is a negative. So again, we're here, but unlike inverse cosine, there's an asymptote right in the center. All right, cotangent. So this one is different than tangent in some ways, because cotangent and tangent are different in where the asymptotes are. So cotangent did not straddle the y-axis, right? And it goes this way. So when you reflect it over the line y equals x, it changes. So you can see that the domain, like inverse tangent, so many different ones, it goes from negative infinity to infinity, and there's no gap. There's no break in this one. It's continuous this way. But unlike inverse tangent, the range is from 0 to pi, which is more similar to inverse secant and inverse cosine. So I have from 0 to pi, and then pi over 2 is here at this point in this line here, pi over 2. So our asymptotes for this are on the outside of the graph, here and here. So here you can see that it approaches y equals x, and up here approaches y equals pi, but will never intersect it. So for here, we have 0 to pi over 2. It's positive. Okay, and that's from 0 to pi over 2. That's here, first quadrant. And then pi over 2 to pi over 2 to pi, this is going to be our second quadrant. And this is where it's going to be negative. So it's here. And then actually our asymptotes are here. That emulates here at 0 and pi. So maybe I'll do it in group. Let's actually do some problems. So before I do them, I'm just going to draw our range for each of them to help us remember. Inverse cosecant is first and fourth. Secant is first and second. Cotangent is also first and second. Here it is here. Asymptote in center. Here. Asymptote in the center. Here. Asymptote at 0 and pi. All right. So when we're doing cosecant, like solving equations, I use the reciprocal. Now inverse cosecant, oh, so many words, is positive, so it's going to be in this quadrant. All right, so I'm going to draw that. So opposite over hypotenuse, that's half over 1. This is going to be 30 degrees. This is pi over 6. Cosecant is negative, so it's going to be in this quadrant, 2. Now, when you do this, you're maybe like, oh, Ms. Mendoza, how do we do the reciprocal? Okay, well, let's just try it. Let's just try doing the reciprocal and see what that looks like. Okay, so we don't like the reciprocal there, so I'm going to multiply by the reciprocal and see what happens to that. That's going to be 3 root 3 over, negative 2 root 3 times root 3 is 3. And this is multiply. Oh, you can multiply at 6, but I'm just going to simplify these 3's, right? So that actually turns out to be negative 2 root 3 over 2. Oh, and I know how to do that. So second quadrant, So it's negative root 3 over here, right? Adjacent over hypotenuse. So this is going to be half, and then this is 1, so this is 30. But our angle is here. Okay. Terminates in the second quadrant. So that is going to be 5 pi over 6. Now cotangent, you can just leave cotangent as cotangent, or you can do a reciprocal of and use inverse tangent. I'm just going to leave it this way, and I'm going to remember that. So cotangent is negative. It's going to be in the second quadrant. So I'm going to be here. Draw my triangle. And this is over 1. So my adjacent is negative root 3 over 1 here. And hopefully you remember this. This will give me hypotenuse of 2. If you divide everything by 2, you can see this is also 30-degree angles. Man, I have a lot of 30-degree angles today. And this is that one, same. So it's 5 pi over 6. Okay. So now we're going to do and review some composites. And then we're going to add secant and cosecant and cotangent with it as well. So you're going to take, and then these are going to be different than the ones that we've done before in that the functions are not inverses of each other. So this is cosine and that's inverse tangent. So they're different, right? And when we do composites, you start from the inside and then you work your way out. So we're going to start here. So remember, we're given a number. That means I'm going to find an angle. So I'm not going to look at the cosine. I'm just going to do this. So for tangent, I have to remember what quadrant. Tangent, positive here, negative here. So we're going to be in the fourth quadrant. And I know it's opposite of adjacent. So this is negative root 3 over 1. Hypotenuse is going to be 2. Divide everything by 2. This is going to be 60. So the angle is going to be negative pi over 3. Now, this is the answer for this part, right? So I'm going to take cosine of negative pi over 3, right? So that's actually the same picture, right? And it's not always going to be in the same picture, or the same quadrant. So I have negative pi over 3. So I'm not going to redraw it, right? Same picture. So now it says cosine. Well, cosine is adjacent over hypotenuse. So it's half over 1. 2 over 2 is 1. So my answer is half. Oh. All right. Sine. Inverse sine, positive, negative. So I want positive. And it is opposite over hypotenuse. So this is going to be 30 degrees. Okay. So that is pi over 6. So this is pi over 6. So I have secant of pi over 6, or 30 degrees. So that's going to be the same. So I'm not changing anything. Same quadrant, same triangle. So cosecant is hypotenuse over adjacent. So that's going to be 1 over root 3 over 2. And that's going to be 2 over root 3. And then that simplifies to 2 root 3 over 3. Yay! I love these. These are fun. So cool. It's like a little puzzle, and you have to figure out all the different parts. Now notice these problems are different than the ones before. The ones before, for these two problems, 4 and 5, the inverse is on the inside. See, the inverse is on the inside. But if you look at 6 and 7, the inverse is on the outside, right? So this is going to be different. So the first thing is you have to actually find a number. So this time you're given the angle, right, instead of a number. So it says 7 pi over 6 cotangent. So 7 pi over 6, that's going to be in the third quadrant. Reference angle is 30. So this is half and root 3 over 2, and they are both negative. All right, so cotangent, that is adjacent over hypotenuse. Sorry, adjacent over opposite. So it's going to be root 3 over 2 over negative half. And that simplifies to root 3. So this is this. So I'm going to tangent and inverse. Now, this is where it may confuse you. These are not like the other problems. Now this is an inverse, and tangent is positive. So we have to remember about our domain for this, or I mean for our range. Our range for this, for inverse trig functions for tangent, it's here. So now I have to move it to the first quadrant. Now the other two I didn't move because it was different. The inverse was on the inside and not the outside. So here it's on the outside. So it's root 3 over here and 1 over here. It's going to be 2 over there. Hopefully we know this is going to be 60. Again, you can divide everything by 2. So this is going to be pi over 3. So if you start with an angle, you're going to end with an angle. If you start with a number on the inside, you're going to end with a number. And yes, the angles, the reference angles now have changed. And they can do that. They don't always, but they can. All right, so let's look at this one. So cosecant 5 pi over 3, that's going to be what quadrant? Fourth quadrant. 60 degrees, root 3 over 2, negative, and then half. So this is going to be negative, 1 over root 3 over 2. That is going to simplify to 2 over root 3, and negative 2 root 3 over 3. Okay, now when we do this, that is the answer for this inside part. So now we're going to do inverse secant. Okay. Now remember, and we didn't necessarily have to simplify it, and maybe I shouldn't have, because this is the same thing as that, and this is probably easier to deal with. So actually I'm going to erase it because they're equivalent, they're the same. It's like saying half and 0.5. Okay. Now this is inverse secant. Inverse secant is in the second quadrant. So it's negative here. And it is hypotenuse over adjacent. So this is 2 over negative root 3. Now the hypotenuse is always positive, so this negative is going to actually go with the root 3. This is going to be 1. If I divide everything by 2, so what angle is that? Well, this is going to be 30. So my angle here is 5 pi over 6. Now, when you do the problems, they're not going to be always the same. So you can have two different problems side by side like this. And you just have to take it and look at it and be like, okay, where's that inverse? Is it on the inside or the outside? And you just have to go with the problem and just go with it, right? So if you want to pause this and try to do them on your own, great. And then unpause when you're done. Or you can follow along. So this one starts with an angle. So at the end, we're going to end with an angle. So sine negative 5 pi over 4. We're going to go this direction, and that lands in the second quadrant. So this is 45. This is negative root 2 over 2, and this is root 2 over 2. So for sine, that's going to be root 2 over 2. So cosine of negative root 2 over 2. So it's positive, and it's an inverse of cosine. So inverse of cosine is positive in the first quadrant. So we're going to put it over here. So I have to move this one. And root 2 over 2, oh, so that's going to be 45. So that's pi over 4. So this one I moved. All right, so number 9, the inverse is on the inside. So I'm going to start with a number. So I'm going to end with a number. Okay, so the inverse of cosine, and it's positive, is in, just looked at that in number 8. It's over here. Adjacent over hypotenuse. Right? So what angle is that? Well, that's a half. So this is going to be 30. Or pi over 6. So cotangent of 30 or pi over 6. Oh, so we're in the same triangle. I don't got to move it. So now I just have to say what cotangent is. Well, cotangent is adjacent over opposite. So that is root 3. I have a feeling you may like the inverse inside better, because you can see that we didn't have to move the quadrants. All right, so here to practice on your own. Again, really look at what function, ask yourself what quadrant they're in, and also notice where is that inverse. Is it on the inside or on the outside? And don't forget to answer the EQ. Thanks so much for watching. Bye.